and welcome to this short video on DHCP. So I'll try to explain the basics of what is DHCP and what do we use it for. I must start by saying that this only covers DHCP for IPv4, as IPv6 that's a whole different ball game, and we do not want to go down that route just yet. In the near future, we probably will have to. So, what is DHCP actually? Well, your computer can get an IP address in three different ways. What just happened there? Three ways. It either it gets it static, dynamic, or it can get something called a paper address. So the static address is where you go around to every single computer you have and type in manually an IP address. It could be 192.168 0 dot, let's call it 10, and then you would have to type in a subnet mask 255.255.255, and boop, and then you will have to type in a default gateway. Mine could be this. And you would have to supply it with some DNS servers, like DNS1, DNS2, if you want to be able to go anywhere or have address translation. But this is basically it. You will have to type this in on every single computer you have. If you only have one computer, that might not be a problem. But imagine if you have like 100 or just a handful even in your home. What we can actually do instead is that we set up a DHCP server, and even the cheapest of home routers have the built-in DHCP capabilities. And this is actually where we come into the dynamics of IP addressing. So instead of going around to every single computer, you just go to your DHCP server and you give it an IP range. It could be like something like you have to type in 192.168.0. Let's say we'll do from 50, and the end of this range would be 192.168.0.100. So that gives us 50 addresses. So this is actually then handed out dynamically by the DHCP server. So whenever a new computer comes onto your network, it just yells out to the network during a broadcast going, "Hello! Are there any DHCP servers out there? I need an IP address." And if there are a DHCP server, it will reply and say, "Oh, I'm a DHCP server, and I have an address. You can take a look at this offer." So that's basically what happens, and they negotiate, and the computer gets an address, and also the DHCP server will take all this information and send along with the address. So default gateway, DNS, a full-blown DHCP server can even send time synchronizations and all sorts of advanced stuff. But the last bit, the last way to get an IP address is this, a peeper. This is what happens if you either are too lazy to give your computer a static address or have no DHCP server. Your computer will actually just assign itself an address, and the address would be 160. Sorry, I'm getting a bit ahead of myself here. We'll just do So you'll get an address of 169.254.0.1.2 blah 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 blah. All this 169.254.255.255. So this is the range of the APIPA addresses. What happens is, if you have, let's say you have a switch. Yeah. Hope you like my drawings. And you have a computer here, and we have another computer over here, and we just plug these two computers straight into the switch. No other connections. They will actually grab one of these APIPA addresses so that they can speak to each other. If they happen to pick the same address, then they will have a collision, and they'll choose another address. So until they both have different addresses, so that chances are that they'll, if you only have two, they probably grab a different address. So that just means these two computers can now communicate on the network. They will not be able to communicate with anyone else. Only on this segment will they be able to communicate. So that is actually quite a lot of addresses we have available for this. So you can actually have quite a big network just using APIPA. But that's not fun. So what we can do is have my little basic home router here. I mean, you've got one in. If you have an internet connection, you have a router. Mine just looks like this. See, it's got this nice shiny Cisco logo on it, but it is actually a Linksys X3000. I know it sounds great. I think it was actually designed by a woman, so that, I mean, even my wife will let me hang this so that she can show it off to her friends. It's that shiny. This baby actually has, I think it's 6 or 8 antennas or something like that all around here. So it's got wireless capabilities built in, and on the back here it's got a 4-port, I think it is 4 switch ports. And that's on the LAN side, and on the WAN side I got 2 ports. One for cable and one for ADSL. Because this one actually has a built-in ADSL2 modem, so I can completely scrap all the pieces I got from my ISP and set that up myself. Except in Denmark we apparently use a standard of this called Appendix B, and this router only supports the A standard. So thank you, Cisco. That was $170 out the window. I could have gone down to my local shop and bought a nice little cheap router for half, perhaps, and still have decent quality. So what I've actually done is I've taken a modem that converts the ADSL signal to an Ethernet signal and plugged into the cable, and that's then routing out to my network. So, but this little baby actually has a built-in graphical user interface that you can access through a website. And that's the funny bit about that, is that, now don't mind up here it says something different, because this is actually ripped off the internet because I can't show you mine because it's in Danish, so most people wouldn't probably understand what it says. But up here you have your WAN connection. So this is set to automatically receive an IP address from a DHCP server. That is your ISP that gives you that address. And down here we have the local router interface. That's the LAN part of it. And this local IP address bit, that's your default gateway. Now, this is the interesting thing that I wanted to show you. The local DHCP server is enabled. So you enter a start IP address of 192.168.1, and in this case, .100. And here you don't actually get to type the end of the range, but you get to type how many addresses you want available, and it does the nice calculation for you. Fantastic. The client lease time, that is number in minutes, and 0 means once a day in this. So if we set this to 8, whenever this computer out here gets an IP address from this router, he will rent or lease that address for 8 minutes. Now that isn't much, because when half the time is gone, this computer is going to go back to the router saying, hey, DHCP server, you gave me this address. Can I have it for 8 more minutes? And the DHCP server will respond, say, oh, yeah, sure, you can have it for 8 more minutes. So it gets it 8 more minutes, and after 4 minutes, it's going to go back to the DHCP server going, hey, DHCP server, I got this address. Can I have it for 8 more minutes? And the DHCP server says yes, and hey, can I have it for 8 more minutes? And yes, and that's just a hell of a lot of traffic. So the default is 0, which is in this case 1 day. You can set it to multiple dates. I think I've set mine to, I think normally if you get a full-blown DHCP server, the standard setting would be something like 8 days. And also here you can set your DNS servers, Win servers, if you still use that. If you don't know what it is, never mind, because you will probably never use it as it's deprecated. So that's the basic of setting up a DHCP server. And we've done it. You now know all about DHCP. Fantastic. So, well, most of it. What actually happens when DHCP starts? It's going to go into something called the DORA process. D-O-R-A. Meaning, your computer will yell out a broadcast saying, hello, are there any DHCP servers out there who want to talk to me? And that is actually called a discover. And so the DHCP server hears this and goes, oh, yeah, sure. I'm a DHCP server. You can rent or lease this address of me if you want. And it's an offer. And then the computer replies back going, oh, sure, that address, that sounds nice. Yeah, thank you very much, I'll have that. And it's a reply or request is actually the right term. And the DHCP server sends an acknowledgement saying, okay, computer, this address is now yours for the next 8 minutes. And that's the whole process. And as I said before, if the lease time is 8 minutes, then when half the time has gone, the computer will now, instead of a broadcast, it will send a unicast, which is actually a direct message to the DHCP server when half the time's gone, saying, hello, DHCP server, if you're not too busy, I would like to keep this address for a little longer if possible, which is actually saying that we skip these two steps and it goes straight to the request saying, can I keep this address? And if so, the DHCP server answers with an acknowledgement going, oh yeah, sure, keep it. It's yours for another 8 minutes. If the computer does not get a reply from the DHCP server when half the time has gone, so we're now down to 4 minutes, it's going to ask again when half the time is gone. So now we're down to 2 minutes. And so it will keep up until it's used up most of the time. And then it's going to start the full process all over with the sending out the broadcast going, hello, I'm a computer and I need an IP address. Are there anybody out there who can supply me with one? And hopefully a DHCP server will be available to answer. If not, the computer will take an IP address and it will be out there on the network all alone and cannot talk to anyone. Unless the other computers have also taken an IP address. But this is actually the basic process of what DHCP is and what's going on behind the scenes. So there's one more thing I want to have in here. If you have multiple DHCP servers on your network, you might have 2, 3, 4, whatever. When the computer goes out yelling, hello, are there a DHCP server out there that can give me an address? All these will reply with an offer. So the computer will actually get several offers, but whichever one gets there first will be the one who gets the request. So if this one is closest, you will send a request to them. And the other will take the address they offered and put it back into their address table saying, okay, I can use this for the next computer that comes along. I hope this clears up the basics of DHCP. You should read the full article for a complete view of what's actually going on. This was just a bit of a fun introduction to DHCP. Hope you enjoyed it. Thank you for watching.